Right, coming to one more question. It was given that you throw a rock horizontally with a velocity of 8 meter per second from the top of a cliff that is 20 meters high, and it hits the ground. Now, how long did it take the rock to hit the ground? So before reading these three questions, let me draw the diagram for the given situation. It will be much easier to imagine. So some cliff is there. Now I'm standing here and I'm throwing a ball or rock exactly horizontally with a velocity of 8 meter per second. So now it will travel certain distance like this and it will fall. Okay, so let me draw it somewhat clearly. So this is a diagram for a horizontally projectile body. Now here at this point there is no vertical velocity. The body is having only horizontal velocity since because we are throwing the rock horizontally with a velocity of 8 meter per second. That means ux at A is 8 meter per second, whereas uy, that means initial velocity in vertical direction, is 0 because we are not at all giving any vertical direction, I mean any velocity in the direction of in vertical direction. So we are just simply throwing horizontally. Now the horizontal velocity will remain constant throughout the journey. So if you take this point, the ux at this point will be 8 meter per second, and even at this point it will be 8 meter per second, and even at this point it will be 8 meter per second, and even at this point it will be 8 meter per second, whereas uy will not be same. And I also tell you why ux is 8 meter per second constant throughout the journey, because in the horizontal direction we are imparting initial velocity of 8 meter per second, and if a velocity has to be changed, there should be acceleration. But since we know that in the direction, in the horizontal direction, there is no acceleration because acceleration due to gravity acts in the vertical direction. So there will be no acceleration in the horizontal direction. So that means the velocity will remain same. So the initial velocity and the final velocity throughout the journey in the direction of horizontal direction will be same. Now, coming to the vertical component of velocity. So initial velocity in the direction of vertical is 0 because we are not imparting any velocity. But because of acceleration due to gravity, because acceleration due to gravity always acts downwards. So it will be changing. So it will be continuously changing, and we don't know what it is. Okay, now, so remember, for a projectile motion bodies we need to calculate the both horizontal component of velocity and vertical component of velocity. So when you are taking horizontal direction, we need to use all velocities and displacements which are confined to horizontal direction. And when we are calculating vertical components like height, vertical direction velocity, we need to confine about the vertical direction components. Now, he is asking how long did it take the rock to hit the ground. That means he's asking us to find the time it hit the ground. Now, let me take along vertical direction. Along vertical direction. The cliff is at a height of 20 meters. Now, along vertical direction, the initial velocity is 0. Final velocity we don't know. We let it be whatever it may be. And the acceleration gravity is minus g. We know that acceleration due to gravity is always minus. So let it be minus 10 meter per second square. And the vertical height is es is equal to minus 20 meters, since the body is traveling from upward point to downward point. We'll take it as minus 20. So now we got u, a, s, and we need to find t. So I can use second equation of motion, s is equal to ut plus half at square. Since initial velocity is 0, so s will become half into minus 10 into t square, and s can be replaced by minus 20. So 10 ones are 10 twos are, so 2 twos are 4 is equal to t square. So t is equal to root 4, which is equal to 2 seconds. So this is very important. Whenever you are calculating certain values which are confined to vertical direction, you should use only vertical components of velocity and displacement. Whenever you're using horizontal direction, when you're taking horizontal direction, you need to consider only the components of horizontal direction. And B question, how far horizontally from the base of the cliff did it hit? That means we need to find range. Now range is something which is confined to horizontal direction. That means here we need to use the velocities and displacements which are in the direction of horizontal. So to find range, so range is nothing but displacement. So displacement, yes, we need to find, and initial velocity is taken as 8 meter per second, because we need to use here the horizontal component, and horizontal velocity will not change according to time, so it is always 8 meter per second. And time, just now we got 2 seconds, so we got a is 0, because in horizontal direction there is no imparted acceleration, so a is 0. So again we can use s is equal to ut plus half at square. So since a is 0, this entire part will become 0. So s is equal to u8, time is 2. So s is equal to 16 meters. That's it. And what is the vertical velocity the rock strikes the ground with? So that means where the rock is hitting the ground. So we need to find velocity there. So at that particular point, let it be B, we can use V square minus U square is equal to 2AS. Okay, so vertical direction, let it be vertical direction. Now when you consider vertical direction, you need to consider all the vertical components. So we need to find vertical component of final velocity. So let it be V square, and U square is 0, because initially the velocity in the vertical direction is 0, is equal to 2 times minus 10 times s. S means here the displacement in vertical direction. So we got it as 20 meters, right? Given it as 20 meters. So let it be 20. And since it is coming down, we need to take it as minus 20. So v square is equal to 2 times 10 times 20. So that is 20 times 20, 20 squared. So v is equal to 20 meter per second. That's it.